Hello, welcome back to AG Engineering. We've got a project here today, a Kickstart shaft for, I think it's a Triumph, could be wrong, PSA, fairly sure it's Triumph. The original Kickstart shaft is very worn, and it looks like it's been underwater for some time. If we put that up to the camera there, you can see where the split, not the split pin, the collet goes. It's worn away a bad edge, and water or something has got to it quite badly. The simple solution of this one is just replace it, but as with all these things, it's never quite that simple. The later ones have got a bigger diameter on the shaft there. See that in the camera. So one of them's what's one of them? Let's zero that. That one's 743 now, so a little bit under 3/4, and the old one is 630, so quite a bit under that new size. So I've got a cover there, a gearbox and timing side cover, and that's the correct size for that. So what's the problem, you say? Well, the problem is this one. If we look at the tooth profile of that, properly, nicely cut teeth. If we look at the tooth profile of our new one, it looks quite honestly like it's been filed out by a 10-year-old kid with a blunt three-sided file. The gear teeth, the ratchet teeth, are absolutely awful. So kind of renders that sort of unusable, really. So the guy that owns this, what he wants me to do is his original one. He wants me to try and sleeve that up to that diameter to fit that cover. So in the process, I can clean up where the cotter pin goes and make it a nice fit for the seal. And I've also got to replace the needle roller in the end there. I've got a couple of needle rollers and a split cotter pin in the back there. So I'll go off and find some suitable material to sleeve that with. I don't really want to take any more off it and make it thinner than it already is. I'll dress up the little bit there that's sort of burred over, and bore out a piece of material enough to press over there and put some Loctite retainer of some version on it. So we'll find some material. I'll get on. Well, that was easier than I expected. A piece of tubing here. I thought I was going to have to bore a piece of solid out. It's welded seam, not drawn over mandrel stuff, but it should suffice for what we're doing. And we've got 840 on the OD and about 597, 590, about 590ish on the ID. So I'll clean the ends of this up and get set to bore it out to just press over there, and then once it's on, I'll put it on. I'll put it on with a bit of Loctite, and we'll let it go off overnight, and then I can set this up between centres type of thing, or in the forge or in a support centre, and then turn the OD and remill the slot in it. So I'll go get this ready now. Right, we'll start off with just squaring off the ends. Set up a boring bar. I'll get ready to bore it to the size of the OD of the shaft. Now unfortunately I've got quite a lot of stick out there on the boring bar, so we'll see how we go with it. A bit of spray cutting fluid. Give me a moment. Okay. A bit of tough cut, Ambersil tough cut there. Bit of a gripe about this one actually. Last time I bought some of this, it was about £7 a tin, and I looked yesterday at some, and it's sort of in the 12 to £14 and higher a tin now. So I think that'll be the last tin of that I buy, unless I find some discounted somewhere. We'll have to go on to a different brand. Unfortunately, I like supporting Ambersil, but not at roll sort of prices. Okay, let's get on with it. Just cleared the back of it there, just. Another 5 now. And I'll check where I am size wise. Shouldn't be anywhere near yet. Okay, I'm getting in the region of about 620, 621 there. Quite difficult to measure on the rotted away part. 622 and probably about 6/10 there. So if I aim for about 621, some bits of it are actually less than that. That's quite a lot less than that at the end there. What I may have to do is build this up with some thick form of Loctite or something. I don't really want to weld it, but as you can see from there, there's quite a step there. The tightest point there, 620, 623, 622 and a half. If I go for 620 and then see where we are. Mm, 613 and a half. Yeah. So another 6.5 there to come out. I'll carry on with that cut there. Initial cut. And just measure at that. No, I overshot that one. 620 and about 3/10. But it's just starting to go at that. Zero that, take the backlash out and come back up to about 1,000, like half a thou less. Okay. And I've got the kickstart shaft in there. I'll give it a little file just to get the raised parts off there. Just going to give it a very light emery, just to give us a nice surface for the Loctite. Clean that end up as well. One of the things I've got to establish before I put the sleeve over this is the position of this flat relative to other features of the kickstart pawl. So I've got it set up there with come around this side with it on a V block clamped down, and I've got the height gauge set, and that's just skimming over the surface there. The surface finish of this pattern one isn't great, it's a little bit choppy, but if I swing that round so it's in the camera, from both sides it's tracing across the surface just nicely. So that's my level point there for this one. You can just about hear it hitting the corrugations, the ridges on the machining there. So then, if I measure this point here, between there and there, that'll give me a reference. Let's find a caliper. On the caliper. Right, it's there behind me. So let's put that on and 0 that. So now that distance there is 156,500, that one. Yeah, it's just scraping it. Let's make a note of that. Now if I do a little sketch of my very rough sketch of my V block, very rough, put him in there. And there's my inner shaft and my dotted flat there. Then the pawl is going round there to there. And that sort of there. Yes, I was always brilliant at drawing. Something along that lines, and that distance there we are saying is 0.1565 to there, and that height, we'll get a measure of that. There is, we're in millimetres on this one, 53.65. That is 53.65 millimetre to the top of there. Let's double check that. Yeah, it's probably just slightly past the 5123 point. Yeah, I'm happy with that. 53.65. So now we've established a depth for machining and a relative position of that nib there with that horizontal on the new one. So that's new. And we'll do the same for the other one. Unfortunately, that surface mostly around there is quite good. Set that up again. And what I'll do is put it on the end there, and I'm going to set that to the same distance there. Lock that there. That's there. So that distance between the side of that and the edge of there is set as the same, 1565. And now, although this distance will be lower because it's a smaller shaft, he says, oh, there's not much in it. It's probably a little bit higher actually. It's less pronounced, that one. So we'll take that up. Move that across. to go with that a bit. Oh, it's going loose. Need to tighten that up. That is a little bit higher up, so it's not machined in quite so so deep. I think when we actually machine that, we can play with that that depth of cut, because it's not critical. Providing the cotter pin goes in and locks, that should be okay. It's quite difficult to see. That's worn. It's got a crown to it on there, so it's quite difficult to know where is correct. There, that's just touching the peak of the crown, but I've got a gap that side and a gap that side, so it's anybody's guess as to what's horizontal with that. I think, as far as we can reasonably judge, if I move that round, would that be any better? No, it's very similar. That's turning that around. That's probably gone almost to the equivalent of a tooth there. This is where you need original drawings to work from, so that you know what you're actually aiming for, or new good parts. That, let's draw it again. Our V block with our shafting. Our height there. Bottom of our V block. That is, as far as I can tell, 51, 2, 3, 4, 54.7, 54.69. Probably a little bit high there, so let's drop that down a fraction. Touching it. It's just touching it. 54.62 on height, and our new dimension there is 207,000. .207. So it's kind of anybody's guess of what we're aiming for there. If that had got a nice level surface on, we could have definitely took a reference from it. So we'll cross that bridge when we get to it. As I say, let's get this sleeve pressed on here. Before I go any further as well, I'm just going to pull this this needle roller bearing out of here, in case we get any problems doing that part of it. Apologies if that's making the camera jump. Let's put that over that side. That out. Okay, finally we're ready. Swap glasses again. Right, we'll give our parts a clean. Bit of brake cleaner. Into there. And we need to remember which way round we're going with that that internal chamfer. Now I'm hoping, just move the camera so it's on the back of the vice. I am hoping here, just winding the vice out, I can press this sleeve on with the vice. Don't think I'm going to do it. Nope. Right. Give me a moment while I just set up the press. Okay, I've just set up the press behind me ready. We're going to be using this Mega Shot, which is equivalent to I think it's Loctite 660 from memory, which is like a quick metal. Quite expensive stuff, and they're very clever because they put it in these damn accordion bottles that make it incredibly difficult to get any out of. And I think half the contents that you want end up squashed into the accordion bit. We'll take a generous dollop of that. Should be sufficient. This is a two-part thing with an activator. With Loctite you use an activator on what they call non-active metals. So things like aluminium and stainless are considered non-active, and brass and things. So you spray this stuff on or brush this stuff on activator to make the Loctite cure. I think this is a similar thing. We coat both the surfaces with the activator and give it a few moments to evaporate. With the Loctite one, I think there's a 7-day and a 30-day version. Once you've sprayed it on the metal, then providing you assemble that part within the 7 days or 30 days, dependent on the variety, the chemicals in it, which I believe are some kind of copper ion, will activate the Loctite, which is a methyl methacrylate adhesive. Give that a generous coating of that. This is a similar principle. And give it a few moments to go off. And as anybody who's ever bought any Loctite 660 will know, it's horrendously expensive. Okay. Now we'll brush a generous coating of this quick metal into here. And this should also seal the path from any oil tracking along. This is used to also repair badly worn parts, badly worn keyways and shafts and things. So this is kind of an ideal use for this one. And there's belt and braces. We'll do the same inside our sleeve. Can't remember what the curing time on this. I think you've got a few hours actually before it starts to go off. It's not epoxy technology. It's it's similar to the Loctite version. Built plenty on there. Use this bit up. I'm not putting it back in the bottle. Because having the activator around it might cure the whole bottle full. Keep going out of camera shot there. Right, I'll just move the camera round to the press. I'm a little bit struggling for space at the moment because I've got my old bandsaw to sell still. Right, chamfer downwards. Make sure we clear any radiuses. Hopefully. That is a good fit. That is lovely. Excellent, and it's squeezed out the excess material there, excess bearing fit. And it's gone nicely up to the shoulder. So there's a bit of excess in there as well, so get that out. Right, we'll leave that for the night, and we'll come back to that one tomorrow and turn the outside down. So yeah, looking good so far. See you in the morning. Bye for now. Good morning. It's the following day, and our pressed-on part should have set by now. Certainly on the part that's sealed from the air. I've had a measure at the shaft of the new one, and that is coming in at 745, so 5 thou under 3/4 of an inch on that one. And if I do the bore measurement on there, coming in at about a thou, maybe 3/4 of a thou under 750. So we've got around about 4 thou clearance on that part. Now I don't know if that should be 3/4 dead or not, but there is, when you put that in, quite a lot of play. So the bore in there looks reasonable. It's a little bit, yeah, it's not so reasonable actually. No, it's a little bit scored in there. So what I'm going to do is turn this down to fit. Probably just give it a thou or 2 clearance on there. So I'll get this set up in the lathe and dialed in, and we'll set to work on it. I think initially I'll just take it down to take that excess off there out of the way, and then we can re-establish a centre and get it dialed in that way. So back in a moment when I'm set up in the lathe. Right, what have we got there? Obviously I haven't got a true surface. I never had a true surface on the shaft that was underneath there because of the wear. I haven't got a true surface there because of the wear. The centre's rotted away as well, and this is just standard tubing, so there's nothing really to pick up on to get a true alignment. So I've got about 15 thou total indicator reading there at that end, and if I move to this end, we've got probably around 5-6 thou that end. I'll go a bit closer into there. That pull clears, yes it does. And we've got about probably again about 5 or 6 thou, maybe 7 thou there. It's certainly not circular. And if I can get onto that portion there, no I can't, not with this clock. Just come out a little bit there, can I? Yeah, it's too worn and rough there, so I think what I may have to do is just sort of, I'll skim this end off first and I'll see what the centre looks like. It's not very clever certainly to look at, but I'll see how true it runs to a centre itself. So let's go for that to begin with. Down to length first.